So in this video, we're going to talk about how to start up the machine. So right now, I'm sitting at the machine. The computer is already turned on, and the controller is off. So I'll turn the controller on. There's a button on the left side of the controller right here. Just press it in, and it'll stay depressed a little bit. And it doesn't matter whether you turn the computer on first or the controller on first. Either way is fine. Once we get going here, if we know who's going to be on which machine each day, you want to do this like first thing when you come into the lab. I don't want you running any programs or driving the machine without me here, but if you want to turn on the controller and the computer, because it does take a while to load, and run it through its homing procedure, I'm okay with that. So you can walk directly over to your computer and at least get up to this point. Now right here, there's a little icon that was bouncing around on the controller. It said Zeiss, and as soon as I see it say ref, which took about, well, I don't know, what was it, 45 seconds? As soon as I see it say ref, and I see my XYZ readout, I can press this little M button right here. So this M button is the drives on the machine. I'm sure it originated in German, but it's just convenient that motor, the word motor starts with an M. So it's turning on the motors that drive the machine. All right, as soon as that's on, we'll double click on Calypso on the desktop. So Calypso icon on the desktop. It'll think for a second, and it will come to a login screen. So we don't have our Calypso configured with a password. You just hit OK, leave the password blank, and it will log in. And again, it'll think for 45 seconds, a minute, whatever it is. And once you see the main Calypso interface show up, you're now ready to move the machine around. All right, before we get there, it wants you to home out the machine. It says, please move the CMM to a clear position. I'll tell you at the end of this lecture how to shut down the machine so that we are sure you're in a clear position. But it's always wise just to look at what you could hit on your way to home position. Keep in mind, we're going to go all the way up in the Z, then we're going to go home in the X and the Y simultaneously. So right now, based on the stylus that I have on the machine, or I'm sorry, in the tool probe, this stylus only points straight down. If you had a long stylus system like this one that points in multiple directions, you could actually hit something on your way home. We have our machines configured so our probe racks are pretty far to the right side. There's nothing really in our way. So I'm just going to say OK. Now, it's also wise to have your hand on this speed knob at all times. This is the most important knob of the entire machine, the speed knob. So all the way counterclockwise is off. The machine just won't move. And all the way like this is as fast as it goes. So before any command, I'm in the habit of going all the way counterclockwise, and then I just back it off a little bit. And by the way, if your machine won't move or is broken, I bet you it's not broken. I bet you it was just left with that all the way in the counterclockwise position. All right, so I'll say OK, and notice that this homing procedure says CMM moving to home position, please wait. It is actually moving, but it is moving really, really slow. When I max this out, you can see it moves quite a bit faster. And you can see how it could potentially hit something as it's moving to home position if you had the wrong stylus on it and it was in the wrong position. So it goes all the way home in Z first, and then moves the X and the Y simultaneously. Now, typically, you notice all the other machines have no probes in the stylus. Or, I'm sorry, they have no probes attached when they're turned off. That's because I typically do a probe change before we turn them off. So that way it's just easy for me to explain. Do a probe change. Now I know you don't have a probe in there. We don't have to worry about this stylus hitting anything on its way home. Simple. So if you want to make sure you're going to get home safely, as long as there's no stylus in there, you're good. If there's a stylus in there and you're unsure of whether it's going to be safe, well, just come ask me. Really, the star would be the only one you'd have a problem with. So now we're homed out and we are ready to move around. So I noticed this stoplight right here. This stoplight should always be on top. That tells you the status of the machine. This is an interrupt, meaning no matter what's going on, just like with the speed dial here, this is a top-level interrupt. Doesn't matter what's going on, I can always control the speed. This is also a top-level interrupt. If you hit the red stop sign, it'll just stop the machine no matter where it is. This software is extremely friendly with resuming where you left off. It's not like you lose time if you hit this stop button. So at any point, you can just hit the red. So now we have a red stoplight. This status window pops up. It says CNC disabled, reinitialize control. No big deal. I'll just X out of that and hit the green again. I'm right back where I left off. So this is called the recoverable stop. If you really have to at any point, you can hit E-stop. You just push straight down on it, but that is a non-recoverable stop. You have to turn the whole machine off, turn it back on to get it back to where it is, because it cuts the power to all the drives. They forget where they are. Right, so that's a general rule of thumb. You know, emergency stop really is for emergencies only. You can use it, but you know, all that electrical power has to go somewhere, so you don't want to be using it all the time. What you really want to do is, if you're ever thinking that the machine might crash, slow this all the way down and control it here. If you really need to stop something, hit the red stoplight button here. The yellow is pause. To be honest with you, I don't use that much because the stop is so easy to resume from. The pause doesn't do much. Here's another way to pause. Just all the way counterclockwise with that, then you can go to lunch or whatever. So these two are super helpful. The stoplight here and the speed slider there. So we want to resume with wherever we left off last time. So the particular lab that I'm going to run here is called the Upright V2. You are all going to be doing the V1 programs. Now the reason I want to do V2 here is, honestly, I was trying to finish this up before everyone got here, and I didn't finish. And I don't remember if this program's good or not. I have so many different programs for these machines on my flash drives. I got about 7 different flash drives that have them on there. I don't know which one's which at this point, so shame on me for that. With that said, I'm not super confident in what's about to happen right here. So I'm going to do this all the quote-unquote right way. I want to know what's going to happen before it happens. So I'll come in here in the main window in Calypso. This is the main window. And I'll go File, Open. And I have already saved this to my Downloads folder. For me, I like to have all of my programs in the Downloads folder. I don't work off of the default locations, because the default locations are like 7 or 8 folders deep. And you got to keep drilling back down there every time. If you just put everything in Downloads, it's an empty folder. It's quick, easy to get to, one click. And the only file you actually need here is inspection. Now, when you run Calypso, it'll give you many more files than just inspection. But I found rather than having files that are gigabytes large, like literally gigabytes large, they get ridiculously large. If you just have a 100 kilobyte inspection file, that's a lot easier to transport. But one thing to keep in mind is when I open that, it might tell me, hey, the selected measurement plan cannot be run straight away. The stylus system is required, or I'm sorry, the stylus systems required are not available on the current system. Now, why is this happening? I actually wrote this program over on that machine over there. And what I learned when I was writing these programs and moving them from there over to here is that stylus system right there, that star, is not the same as that star or that star or that star. They're all different. They all have different calibration results. So if I simply name them star, 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 when I take them from over there to over here, it actually uses the wrong calibration data. So your parts look like they're bad when they're good, or they look like they're good when they're bad, or whatever. Not good. So what I did instead is I named that stylus system star_1, star_2, star_3, star_4, etc. So that way it flags you. It'll tell you, hey, this is not the same stylus system that was originally used. Now this is something you typically don't have to worry about when you go to a company because they don't have deep freeze on their computers. Is that a ringtone?
Yeah.
Yeah. So the company that you're at probably won't have this issue, but we do because we have deep freeze, and deep freeze resets the computer every time you turn it off. So we have different stylus systems on every machine. I know they look the same, they have different calibration data, they have different names to them on purpose. So when it prompts you, it says, do you want to open the plan as it is, or do you want to exchange the stylus system? You'll just hit OK. It'll bring you to this menu. And it'll tell you, hey, this says default right here. It's not available on the system. Shows you in red. So I'm going to click on whatever's red, and I'm going to hit the pull down. And unfortunately, I have to already know what this stylus system should look like. So there's a lot of room for error here. That's why the first couple of programs you're going to run are very, very simple. So that way you don't crash your machine on your first day. We'll wait until like week 3 or 4 for you to crash your machine. Just kidding. Hopefully we won't crash them at all. Right, so in this case, I do want to grab star 4, and that drop-down list only shows me what's available in this machine. Right, so it says, do you really want to execute the changes marked with a little hyphen, I don't even know what that symbol is, less than bracket, greater than bracket? Say yes. So that made its best attempt at modifying my program based on the probes available, but it's not perfect. So next thing we're looking at here, we do have the ribbon up top. We can get everything from the ribbon. But we also have our icon menus, which I really prefer, and you can get most things from the icon menus. So right here, you could, in SolidWorks, they call this what? The feature design tree. Vericut has the project tree there. Mastercam has the toolpath manager there, right? So we'll call this the, geez, I guess I should look up what this is called. What do we want to call that? The measurement tree? We'll come up with a better name later. I'm sure it's like written down in the documentation. Let's call it the measurement tree. So if we go to the left tab of that, that's CMM, and it says CMM settings, and it's green, stylus system, and it's green. So that means it knows the CMM we're connected to. It knows the stylus system we're using. That's awesome. Let's move to the next tab. That's our measurement tab. I see something yellow here. Well, it knows what our alignment is, and it knows what our clearance plane is, but it doesn't know our report, measurement plan editor features isn't populated, and that our temperature compensation is yellow. Well, we don't have temperature compensation on these machines. Temperature compensation is a little thermocouple. You'll learn about it in Curio Z. It's like a little piece of brass that has a wire coming off of it. You can put it on your parts, so that way whatever temperature they are is being fed into the machine. And this is a really big deal for inspection. We didn't pay for that option. We just keep our room at 68 degrees. And also we make scrap anyway, so it doesn't really matter. But one thing I will do in this measurement tab, I'm going to click on Measurement Plan Editor Features. And that's because even though it told you it changed the stylus system, I've come to learn that it doesn't actually change the stylus system. Maybe we'll learn later I'm just doing something wrong. That's probably what's going on. But this is our feature plan editor. I'm going to come up here to the main pull down, and I'm going to go to Stylus System and click on Stylus System. And notice that these are all red. So we can use all the same Windows mouse gestures that we could use anywhere else in Windows. I'm going to click on the top option, and then I'm going to hold Shift, and I'm going to click on the bottom row there. And I'll hit the pull down, and instead of setting them to default, I'm going to set these to star 4. That's the one that it should use. At least, I think that's the one it should use. Notice that they all turn black now. That's good. I'll say OK. All right, so now we at least know which probes we're using. Let's move over into our characteristic list in the inspection tree. Is that what I said we were going to call it, the inspection tree? Sure. You watch the video later. Let me know if I'm wrong. All right, these are all of our characteristics. You can think about it like this. Characteristics are things you care about. They're things that will be exported to the dimension report. So we're going to export flatness, x value, y value, diameter, perpendicularity, etc. Notice that these are all gray, because while they are defined and they know what they should do, I haven't actually put any measurements in there yet. I haven't touched points on this part yet, so that it knows where those features are. So gray is good. It means it knows how to do it. Green is better because it means it knows how to do it, and it actually did it and got some results. So let's move over from the characteristics tab over to the features tab. So in the features tab, we can see all of the different features that we're going to measure in this program. Remember, characteristics is what you care about. That's going on the dimension report. You may need to measure some features just to find the part. In fact, that's true of every program. You need to measure at least some features to find the part, and that's called an alignment. Some of these features are just finding the part. Some of them are actually outputting information to the characteristics. So it seemed a little hokey to me at first that this was divided into characteristics versus features. As you get a little deeper into this, you'll see there are many very good reasons for why they do it that way. Here's what I like to do, though. I'll go over to the features tab, and I'm just going to kind of wrap my head around what this should look like and what sort of features we'll be measuring. So I'm going to click on plane 1, and notice that it highlights it in the graphics screen. And did you notice also there's no CAD model with this program? It would be really nice if there was a CAD model with this program. Also, it doesn't even tell us what our fixture is supposed to look like. How are we supposed to know that? Well, when I post these files out on Blackboard, I'll give you a couple of files. I'll give you, number one, the inspection file. Number two, I'll give you a setup.jpg. It's just a graphic, an image of what the setup should look like. And I just take a picture of that on my phone and I email it to myself, put it up on Blackboard. So the picture shows me that I should have it on this fixture sitting up about that high. And a lot of times I'll add a CAD model to that program as well that will show you even more detail about that fixture. And this can be really important when you see some of the clearance issues that we have going on with this part and other parts. But for right now, I don't have those luxuries. I'm not looking at the picture. I'm just looking at the graphics screen. So I'm going to have to think really hard and then also do a simulation before I run this to make sure it's going to run correctly. What sort of simulations do we do on a CNC machine before we actually cut a program?
Graphic and dry run.
Graphic and dry run. Well, this has something very similar. It has a graphic run where you can simulate fully, and CurioZ will give you a lot more details about this. It doesn't really have a dry run, because with a dry run, typically you would back away your offset and you wouldn't actually cut the part. Or for rotary axis programs on a CNC, you don't want to back away because now you're not checking collisions. So you remove the part, you run the program at full depth. So you would think, hey, maybe I could just run the part or run the program without the part in there. The problem is the CMM builds its coordinate system by touching the part and finding it. So if you can't touch the part and find it, you can't run the program. So yes, you can do a graphic simulation. It simulates right on the screen. It's very slick, very, very cool. But you can't actually do a dry run. So our equivalent of a dry run is called step mode. It's a lot like running a CNC machine in single block, right? Now when we're cutting parts on a CNC machine and we're milling out the outside profile of a part, we can't just hit feed hold and just leave the tool spinning there against the part, right? You kill the tool. But luckily on a CMM program, you can run it in step mode. It doesn't care. So really we do have graphic and dry run still. Graphic run is graphic run. Dry run is step mode. I would put that in your notes. We're going to do that for this program. Now also, I'm going to go through and just look at which elements we're going to measure here, which features. So that way I have a better idea of what's going to happen. So the first one I see is a plane on the top. And I'm just clicking on them through the list, or you can click the down arrow and it'll show you what's what. So even if you don't have a CAD model, it gives you a wireframe CAD representation of what the feature is. So we have a plane on the top, we have a 2D line on the front, we have a point on the left side here, we have a cylinder on the left side, cylinder on the right side, a 2D line on the right side of the part over here, and a 2D line on the left side of the part there. And that's a little bit, I'm not so sure what's going on with that, because I can't really tell if the 2D line is right here or if it's underneath the part. And my intuition tells me it's probably underneath the part. Number one, it's not really my intuition, it's my memory. I wrote the program, right? So I know that that's what it does. But also, why would you put it on a standoff if you're not going to measure underneath? And why would you use a star probe if you're not going to measure underneath? You probably wouldn't, right? So I have a sneaking suspicion we're measuring from underneath. And whenever you measure from underneath, or if you're measuring with a star probe, you got to be very careful about how you move around the part. Okay? And then we have another plane here, and that plane is actually connecting those two lines together. It's taking all the information it got from those lines and then putting it through a different algorithm where it can look at it as one continuous plane rather than two independent lines floating out in space. Right? It's like basically we married those two lines together. So that's what we're doing. So how do we get a better idea of what we're doing before we actually do it? Well, let's pop back over to the CMM tab. So I'm over here. And let's go to CMM settings. And notice that we have Duramax in simulation. Turns out you would think that you can just click on simulation and it would simulate fine. It doesn't work like that. But what we can do is we can check on this box that says simulation only at the top. Simulation only, and then we'll say connect. So we just disconnected this machine from this computer, essentially. And it does take a second to think. Now notice it doesn't know what stylus it has or anything like that. All right, so we'll come over here and we're going to do our graphic run first. So to do this, we have two different general ways we can do this. We can run from our characteristic list or our feature list. Now remember, our characteristic is things we care about. Our features are the actual things that we're going to measure on the part. So it can be, this is context dependent, depending on what you're trying to do. If you just want to acquire information about this plane specifically and you don't want to output a dimension report, maybe you run things from the feature list. If you want to just get dimensions off of everything, you're probably going to want to run from the characteristic list. And in this case, that's what we want to do. We want to run from the characteristic list. So I'm on the characteristic list. Then I come down here and I click Run. All right, and this window is just going to be an albatross around your neck for a while. There's a lot going on with this window. There are a lot of what ifs. I've been really racking my brain trying to think of the easiest way to explain this to you. Maybe at some point I'll figure out how, but as of right now, I don't have a great way of explaining it to you. Here's a great way of explaining it to you, though. Figure it out. Right, so you're going to go through it and you're just going to figure it out. I will give you some pointers. Some pointers are, anytime you're running a job that was programmed in a different session, like you programmed it last week, or I programmed it on that machine, or something like that, the first thing you want to do over here in the left side of the window, under Selection, is you want to do a manual alignment. So in this pull down right here, which is grayed out because I'm not on the actual machine, in this pull down here, you'll have a whole bunch of options. The top 3 options are going to be manual alignment, current alignment, and then there will be whatever the name of the program is, which oftentimes will be measurement plan 1 if you're writing your own program. So you got 3 different options there. Again, I still don't have a great way of explaining this to you, but I will say, if I tell you what all 3 of those options are right now, that'll be the rest of lecture today. We won't get anything done. So here's a simple way of thinking about it. If you always do the manual alignment, you'll never crash anything, but it will take longer. If you do the current alignment, you'll probably get yourself in trouble. If you do whatever your part's name is, measurement plan 1 is kind of the default. If you do that, that's like running something in production mode. This machine's already turnkeyed, it already knows where the part is, you already ran it today, everything's fine, you're just inspecting part number 565 out of 1,000. And you just inspected 564 others. So you got 3 different things you can do there. When in doubt, do the manual alignment. Right? At the very least, it's practice moving around with the joysticks. So you want to look up here and make sure you have the correct setting for your alignment. The top 3 options are the only ones you'll ever use. The rest of the options, I would just delete them from the software if I could, but I can't. So there's going to be a whole bunch of extra text down there. You only need the top 3. All right, then next, we have all characteristics or current selection. Well, all characteristics is exactly what it sounds like. It doesn't matter what you have selected in either of these windows. It's just going to run every single characteristic that is available in the measurement plan. Right? Calypso calls this whole thing, by the way, the measurement plan. Right? So the file is a measurement plan. Right? So if you run all characteristics, you do everything that's in the characteristics window. Now, a lot of times you only want to do like 1 or 2 things. Like you're writing a program, you're halfway through writing a program, you already inspected pretty much the whole part, but you added, oh, I forgot to check the depth of that counterbore. Maybe all I want to do is run that one feature where I touch the depth of that counterbore and that's it. Well, if that's the case, maybe you want to do current selection instead. And if you do current selection, that's going to grab whatever you have highlighted on the screen here. And that's why I say this is context dependent, because whether you're in the characteristics list or the features list, you're going to have different selections. Right? If I have the top 3 of these selected, my current selection is going to be flatness, x value, y value. If I'm in the features list and I do the top 3, it's going to be the plane, the line, and the point on the left side. Completely different, right? So that's why I say this is going to be an albatross. There's a lot to this menu. But so far, I'll just say, as a good default for your alignment, manual alignment if you're not 100% sure, and all characteristics if you're not 100% sure. If it doesn't do what you want based on that, come get me. All right, so that was all in the selection heading. Then we have the result heading, and this is saying, what do you want me to do once I acquire all this information? When you run programs that I give you online, I'm only going to give you the inspection file. I'm not going to give you all the frills. So if all you have is the inspection, it will be missing a whole bunch of stuff here. It won't even know what dimension report you want to output to. In other words, it doesn't know the format of how I should output this information. So if it's missing something up here under multiple report, just hit the pull down and select the top option. It's default PyWeb reporting. So if it's ever missing, or if it tells you, hey, I don't have a dimension report format, just grab the top one. That's what we use by default anyway. Ignore everything else in here, in the results section, other than clear existing results. That's a whole separate conversation about clearing existing results. That's right, this is the most complicated menu in the whole software. So, when in doubt, if you don't know if you should clear the results or not, clear them. The worst thing is you have to wait a little longer for it to go probe some stuff. I'll tell you a lot more about this later, right? You kind of have to have run the machines and compiled a whole bunch of just watching them run in your head before you even know why this matters. But for right now, I got to tell you at least a little bit about it so you can run it safely, right? Safest way of doing it so far, manual alignment, all characteristics, default PyWeb reporting, clear existing results is checked on. All right, and then we have the CMM tab. In the CMM tab, we have a whole bunch of things that'll really change how this works. The biggest one that I want you to worry about right now is the speed. The default speed that we're going to use at stick is 40 millimeters per second. Why? Well, once you know how to run these machines, we'll have another discussion about what you can do for your speeds. If you go any faster than 40 millimeters per second, you can damage the probe itself. And that is $15,000.
When you say 40 millimeters per second, you're talking like max speed on the knob, right? You still can turn it down, right?
You can still turn it down.
Yeah.
Okay. Yep. So this right here, well, I disconnected from the machine. So this doesn't know what I'm doing right now. But that right there is about, I'm going to guess, 100 millimeters per second. The machine can do 300 millimeters per second. So if you are not paying attention to that, it assumes you know what you're doing, and it'll go 300 millimeters per second. And if you're not on top of this, geez, you could just break the entire sensor immediately. 15 grand in an instant. So I know there's a lot to pay attention to in this menu. Probably the most important thing, maybe this is what I should have started with, is that speed wants to be 40.
Well, 40, not 400, right?
40. Yeah, if you do 400, it'll do 300. And there's still no substitute for just slowing this down too and being on top of this. So that basically, that doesn't do what you would think. You would think that would set the max speed to 40 and then you have adjustment there. The max speed is always 300. That just says if you're above it, only do 40. So really, you have this tiny little window, when you're at 40, you have this tiny little window to adjust the speed, and that's it. Not very much resolution at all. So I kind of don't like that, but hey, that's what it is. On our other machines, you can't even adjust the speed, so I'm happy to have something, right? The other ones, you just cross your fingers, hope it doesn't break itself. All right, so another thing here, under run mode. So under the CMM tab, under run mode, you have normal, slow through first feature, step mode, and manual. You'll never use manual. The other ones do exactly what you would think. Normal just goes full speed all the time. Our default is going to be slow through first feature. So that way, no matter where you left the probe, it'll at least get over to the first feature slowly. Because if it's going to crash, that's probably where it's going to crash. Somebody probably just left the probe in a spot that was not safe, right? So under run mode, slow through first feature is what we want. Now, when you're trying to do a quote-unquote dry run, there is no dry run. You'll do step mode instead. Step mode is going to go only one feature at a time. It's a lot like running in single block on CNC. Right, so I'll do step mode here. Now, I hate this. I'm about to hit start here, and I forgot to open up the simulator. So go ahead, I'll hit start. It's not going to show me anything. It just says switch to CNC run, continue. So I can keep hitting continue, but I don't see anything happening. right? It's thinking, it's thinking, it's thinking. This is not helping me get any information unless I'm like Neo from the Matrix and I'm reading through whatever that gobbledygook is. But it is acquiring information right here. That's pretty impressive, right? I don't know what it thinks it's doing, but it's got some red and some green. So you notice how in the characteristics it turned from gray to either red or green, right? Gray is I know how to do it. Green or red is I've done it, and it's either good or bad. So you can see I just have to hit continue to go through everything. At the end of that, it's going to generate my report. Well, that wasn't really helpful for what I'm trying to do. I'm trying to just watch what's supposed to happen and see if it's correct or not. It is kind of cool to know that it can generate the report that way, as long as it has results. So there's our report. Whenever the last time I ran this part, that's what I got. That's not what I care about now, though. I want to measure this part. So I'll get out of this. And what I should have done beforehand is I should have come up here to Planner, and I should have clicked Measurement Plan Simulation. So hey, look at that. Doesn't that look like our sensor? Apparently our sensor is, that's funny. It's not configured in this machine, which now that I see that, we will have to fix that. Hopefully this won't be this way on your machine after you follow that document. See the extra vast XXT here shouldn't be here. You should just see the star probe itself. But now that I have this open, I'll go back to that run menu and I'll do everything exactly the same as I had it. And hey, look at that. It's actually simulating the part now, and it's showing me what should happen. So now you can see why I'd really like to have the CAD model here, instead of just having that wireframe view. And you can also see why it's so important to configure your sensors properly. Again, I'll have to fix that. Because what we're actually seeing here is the probe is down here, and this is the sensor of the machine. It thinks it's lower than it really is. And that down probe, the one down here, is touching some of those features on the part. So CurioZ will go into a lot more detail about this. But you can slow down the simulation speed. This is quite hokey. I have to race it to slow down the simulation speed. There we can see the probe did come underneath, and the left-facing probe came up and probed that from the right side. And then we moved over to the other side. It actually looks like we crashed moving to the other side. Then we come back up to the top. So I don't expect that to be too meaningful to you yet. What I do want you to remember is that when you're configuring your probes tonight or whenever you do that on your Calypso and it feels like it's a lot of work, yeah, it is a lot of work, but it's worth it because that makes sure that that runs correctly. And that's what allows you to see if your programs are written correctly before you get here and waste time in class. The second thing is, that told me that I was not navigating in a safe way, so I'm going to come in here to, what am I missing here? Apparently I froze up there. So that told me that I was not safely moving from one side of the part to the other side of the part. And now that I know that, come on. Alright, I guess we'll pause the video and restart the software. And by the way, if you ever have to restart Calypso, this doesn't happen often. This is a very robust software from what I've seen. The software itself is called VWNT 32-bit. So just click on that and click End Task. And I just force closed it. And then I'll just launch it again. So I just did my graphic run. My graphic run told me generally what the program is going to do. I know that I have a potential collision on my hands. Now I'm going to go back and reconnect to the machine. Now when I force close the program, it lost the changes I made to the probe, so I'll go remake those really quickly. You'll get used to doing this quickly because it's going to happen every single week. All right, so that all looks good. Now another thing is I disconnected from the machine. I put this into a simulation mode. So right now the machine can move via joystick, but I can't control it via the computer. To connect back to the machine, I have to go back to CMM settings, and you see where it says simulation only? And that was checked on. I'm going to check it off, and I'm going to say connect. And while I'm connecting, I'm going to just slow the speed slider down as well. So this kind of wants to always be at the top of your mind. You notice I mentioned that multiple times already, and we haven't even really moved the machine. This kind of wants to be, anytime you think of a new task, it doesn't hurt anything to look at this and slow it down. Every time. Because otherwise you exit some procedure that you just did, or you have something weird happen, like what just happened. If you're not used to looking over here, at some point, you're going to leave that like that. You're going to do something and hit start, and it's going to go smack. All right, so I just reconnected there. Now everything's happy. That problem that I saw can be fixed by doing block edges, and we'll talk about this later. Basically, I am now telling the machine that you cannot move around the part like this, because in this program, when we're switching from this stylus to that stylus, we're over here, and it pulls off like this, goes like that, and then tries to ram this stylus through the part. And this, by the way, is why we are not doing star stylus until at least the second half of the semester. Right, so I believe I just fixed that, but am I really super confident in what's happening here? No. So I'm no longer in simulation. My graphic run is good. Now I'm going to go do the dry run. So here's how you do a dry run on the machine. I'm going to hit run. And by the way, I programmed this job on that machine over there. I just happened to turn on this machine today. Does this machine know where I put that part? No, this machine has no idea where I put that part. So which one of these alignments should I pick for base alignment under selection? Should I pick, well, first of all, I don't even have a pull down.
Wait, what do you have? That's what do you have for options?
Yeah, I don't even have options. And the reason I don't have options is because clear existing results is not checked. I need to clear whatever results are there. Now I got a whole pull down. So now you can see this is what I was talking about with a ton of these different options. You're only going to use the top three: manual alignment, current alignment, and then whatever the measurement plan's name is. Apparently this measurement plan's name is 001 or 0100 underscore one hole underscore master. It's whatever I named the file. So what do I want to do here? I said when in doubt, use manual alignment, right? Manual alignment tells this machine where I put that part. And by the way, that part's there right now. If I want to run the part like that, I have to do another manual alignment because I moved it. But because I put this fixture up against bump stops being there, I just bumped it up against the surface plate. There, I just bumped it up against two set screws. And there, I bumped it up against a third set screw. That's going to locate pretty well within plus or minus 5 thousandths probably. So that's a relatively repeatable setup. So as long as I know where that is, if I've done a manual alignment, I could take this completely off the machine, put a different modular subplate on there, right? Like I could do this. Get that off. I could go grab this setup. I could pop it on right here. Run this job for a while, right? And then some other operator comes back in and they have this part again. Well, I can pop this back on that same bump stop. That location is more or less the same as what it was before, right? Within plus or minus 5 thousandths in any direction, rough numbers. Well, that's why you have these named alignments. So that way I can have every job I've been running on this machine already knows where it should be as long as I didn't change that fixture. But what if I loosened up these bolts here and I physically move this on the subplate? The blue thing is the subplate. Well, now all of a sudden I need to realign it. I just need to tell it, hey, I moved this. Right, so that's why it's structured in this way. Here's what I want you to put in your notes. Manual alignment tells the machine where the part is. When in doubt, do a manual alignment. The only thing you'll spend is time. All right, so we'll do a manual alignment here. It's because the machine doesn't know where this part is. I programmed it on a different machine. It's a different day. Cheap insurance. By the way, here's another quick way of doing this. I can't do it right now, but there's on your stoplight window, there's a little pull down that says CMM system. You can set that to part coordinate system. In fact, let me do that right now. Or it's called base alignment. And you can drive over to where you think this ought to be. The coordinate system for this part is supposed to originate right here. My X says 420 thousandths. My Y says 2 inch 356 thousandths. And my Z says minus 240 thousandths. Right there, that should be very close to X0, Y0, Z0. Okay, well that's just a call sign for, do I need to do a manual alignment? Yeah, otherwise everything's going to be shifted by 422 thousandths in the X, 2 inch 356 in the Y, and whatever in the Z. So that's a quick way of telling, do I need to do a manual alignment? Drive to where you know the origin is, make sure those say 0, 0, 0, or something very close. Yep.
So that Nomen in the graphics, is that where the origin point is?
Yes, that's a good question, yeah. So this Nomen right here in the graphics is where the origin should be. And that goes to show you why it's so helpful to have a CAD model too, because the CAD model gives you the context. Now here we could kind of piece it together based on looking at this. How much better is this if we just went CAD file load and sure, I probably deleted the CAD files off of this. How much easier is it to see where things are? The CAD model is just right there in front of your face. Now granted, this CAD model is in the wrong orientation and location, but it just goes to show you, like, yeah, that Nomen will tell you exactly where things should be. Now that CAD model did come in the wrong orientation and location, and we'll go over that later in the semester, but for right now, I want to just get rid of that so that way I don't accidentally think it's the wrong thing.
You were able to, if that happened, you were able to change the orientation?
Yep.
Okay.
Yep, and CurioZ has some modules on that are really, really good. That's like the best module out of the whole class that I've seen so far. So if you're curious about that and you want to work ahead, please work ahead. I'll accept the submissions whenever you do them. So yeah, there are modules on that. We'll also be going over that in class as well. You know, the CAD model starts however the CAD model starts, but that's not usually useful for how you're going to inspect it. So there are tools in there where you can orient the part differently. You can add fixtures in there. Hugely powerful. All right, so anyway, that's that. I have the wrong probe active right now, so I'm going to fix that. So probe 1 is active. I see that here. It was probe 3. That would have gotten me into a lot of trouble. And also, the CNC machine seems to think that I have star probe number 4 in the machine. Is that a star probe?
No.
That is not a star probe, so I gotta go get a star probe. So I'm gonna do an automatic tool change. So that's this little A. It's always in the top of the window whenever you're in Calypso. And notice that the 30 by 1.5 by 4 is selected. I want star 4. Now, these are the probe racks as viewed from the top here. And this is kind of funny. The probe racks come in 3s, but they only have 5 wide here. So that is actually talking about this. Watch this thing do a tool probe change. I'll highlight it in green, right click, and say load stylus system. And right now, it seems to think that the stylus system that is in there is this stylus system, and that's not correct. That has to do with how I loaded up the program initially. So long story short, it doesn't know what's what. Ignore what I'm about to do here. I do not want you to do this. The reason I don't want you to do this is if you pull straight down on that, you can ruin the $15,000 sensor just by doing that. It's got some very sensitive springs in there. So we're only ever going to do tool changes in this class automatically, and if for some reason an automatic tool change isn't working, just call me over. It's just simpler and cheaper that way. Most of the time this is extremely robust. Every once in a while it gets lost like that. That probably has to do with me force closing the system as well. If that's the case, you do not want to just do a tool change. And also, every time you do a probe change, you want this to be going slow, because if it thinks it has no probe on there, but it really does have a probe on there, it's going to smash that probe into the other probe. When this is working properly, it should look like this. Can you imagine if it did have a star probe on there and it came into another star probe, what would have just happened? And this is what it looks like when it's working properly. If I want to grab the other one, it's super quick and easy. It's smart enough to know what's there. It's just if it forgets what's where, that's a problem. So it'll even do this in the middle of a program if it needs to. Okay, that wasn't the one I wanted. I want this one. So get in the habit of always having your left hand on this speed slider. Whenever you start a command, just slow it all the way down and then up a little bit. When you see it start doing what you want, then you can speed it up. When we first got these machines, I did that like 10 times in a row. It's just super cool to me. All right, so I have the correct probe in position. Which probe does it think I have? It actually thinks I have probe 2, but I want probe 1. So we have a little button for that here. You won't have to worry about this in the beginning because we're not using star probes. But there's a little button here that is designed for a star probe. You want to make sure the icon on this readout matches what you actually want, and this one will follow. So we have probe number 1 active, and we are now going to come over to our characteristic menu and hit run. We said we wanted to do clear existing results and manual alignment. What do we want to do for our run mode? We want to do normal, slow through first feature, step mode.
Slow to first feature.
That's what we want to do if we already know what's happening. But do we know this is going to happen correctly? No, so we want to do step mode. And step mode is the equivalent of a dry run. So I would put that in your notes. Step mode is the equivalent of a dry run. So I'll hit start. Got my thumb on the speed slider here, my hand on the speed dial. And the first thing it asks me to do is the manual alignment. So it wants me to take 1,600 points on whatever surface is shown in gray here. So this might take us till the end of class. I'm just kidding. We're not actually going to take. We're going to take
3 alternative.
The minimum number of points for a plane is 3, so we'll take 3. You only need to take the minimum. You can take more than that if you'd like, but I always take the minimum because this is just a rough alignment, as you'll see. The machine will go back and reprobe all of this. So right here, why is this going so slow?
Is your knob turned on? Or wait,
Your speed.
It's because of my speed slider here, but it also could be affected by how fast you told it could go. So if you told it could go 40 millimeters a second, it's only going to max out at 40 millimeters per second, no matter where that is.
I have a question. The 1,600 points that it needs to take, is that like a default or?
Nope. I set that up.
Oh,
when
you
I
set that up.
wrote the program. That's actually for scanning. You wouldn't ever see points more than like 50 unless you're scanning. And when you're scanning, you can have an absurd number of points. So you can see it logged the points there, and it's actually showing me where these points are happening on the screen here. It's showing me my 3 points. So these 3 points look like they're shifted off in space, right? Well, that just means last time I ran this program, the part was over here in the machine's volume. And by the way, it was on that machine, not this machine. It's got nothing to do with it. But those points are showing you where you should be touching on the part. The fact that they're misaligned, well, yeah, it's because I'm updating my coordinate system. This is why you can't do a dry run with the part out of there, because it needs to find the actual part to be able to run. It's creating its own context as it's going. All right, so I'm done with those 3 points, right? So I could do the other, what would that be, 1597? That would take a while, so I'll say OK instead. Boom, runs right on to the next one. Now it wants 22 points on the front line. Man, it would be nice if we had a CAD model in there, right? Unfortunately, in the beginning, I didn't give you CAD models on pretty much any of the programs. Why? I want you to suffer through it a little bit so you see why you need to add the proper documentation. I want you to feel what it's like to be an operator. Somebody else wrote the program, you have no idea what's supposed to go on, and you're nervous. And then you can take that with you, and I want you to have just a little bit of PTSD over it so that every time you're writing a program yourself, you're like, that sucks. I'm not going to do that. I'm going to do it the right way.
Now, when you're programming here, are you making contact with the piece?
Yep, and you can just drive it right into the piece.
Will it know
Like
not
that.
to go any farther once it makes contact?
It knows not to go any further. Yep.
Okay, because I was like, you seem pretty like with it to not be so like delicate about it. You know?
Yeah,
So
I'm
I
just
was
that good. No, these machines, no, these machines are super friendly about that.
Nice.
As long as you're not just going super fast into it, like that fast into it, you
Yeah,
won't be
yeah.
able to stop fast enough. Same way as if you're texting in your car and you're in a parking lot and you bump into somebody in front of you, it's like, yeah, they might get out, rough you up a little bit, but they're not going to care that much,
Yeah.
right?
That's a little
But if you're doing the same thing on the highway at 65 miles an hour and traffic stopped in front of you and you're texting and then you hit somebody in front of you, that's worse. Same thing here. If you're going slow, it'll take care of it. If not, that's not good. So minimum number of points for a line is 2. So I'll say OK. Then we'll come over here and we need a point on the left side. It shows me that right here. So we'll do that. Then it says, caution, CMM being changed to CNC mode, move stylus system clear. I'm moving it clear, slowing this all the way down, and then a little bit above the slowest, and say OK. Now it's steps, and it says, do you want to go? Continue. And it's going to give me all these annoying alarms, but what I like about those alarms is, watch what happens when it's running. If I had this at slow speed, look at what happens to the scan path. It's scanning right now. So you want it going slow because you don't want it to wrap it to the next feature quickly. But if you don't have step mode on, you end up having to have this at full speed, so the scan's at full speed. And then at the end of the feature, it rapids to the next feature. Well, that's the whole problem to begin with. I want to know how it's getting from feature to feature. So right now, do I want it to be at full speed when I hit continue? No. So back down, hit continue. Okay. By the way, look at where that speed slider is. That's like less than a third of its total capability. So this is pretty sensitive. So why do we do things in step mode? Because of what you just saw, especially if you're scanning. Now, also in the beginning of the semester, we are not going to cover scanning. Scanning is high precision. Well, high precision is high cost as well, right? We're going to learn the simplest way of doing this. We're going to touch points instead of scanning. That's also a lot easier to learn on because you don't have to have the speed dial maxed out to be able to scan at the right speed if you're just touching points. All right, and I have a meeting I have to run off to, so I think I got another couple minutes, but we're just about at the end of class here. See how painfully slow the scan path is when you're running the speeds dial anything other than full speed? You're also influencing the results of your measurement by running this anything other than full speed. So it will be slow going when you run in step mode, but the cost of skipping step mode can be huge, right? Again, 15 grand right there. Okay, now separate from this, that scan is a lot slower than it needs to be, so I can edit that, make it faster.
Yeah.
Yep.
So when you first started to scan, you did the front on one side. So how does it know what the back side is, where it is right now? Because of the model?
So those are great questions that I'll answer later when they're in context.
Okay.
So it doesn't know anything unless it touches it, basically.
Okay.
And when I write the program, I can do 2 different methods. One of them is teach-in programming, where you're basically teaching the CMM where everything is by touching it in the real world. And then there's also CAD programming, which is if you're running Calypso offline, you can use the CAD model to define where all this should be. Now, how did it know where the model is to go over here? Okay. Also, see how fast that was? Did you see how much I rotated the speed dial to change that speed? It was almost nothing. I mean, it was only, the difference between here and there. So I'm just trying to get you to have some buy-in on the why we do step mode. Again, 15 grand. I know I said it a bunch of times. I'm going to keep saying it. It's still 15. It didn't change costs since I started. Now also, it was going to crash right here, and you probably didn't see it in the simulation, but I noted like, hey, that doesn't look good. I'm going to do the black edges thing. If it was going to crash, it would crash right here. And step mode stopped it, so I can slow this down. And I'm going to watch how it's moving over to the next one. And you see it moved above the part and then over to the other side. That has to do with clearance planes and clearance cube, and it is not a given that it knows where the part is. It only knows what you tell it. So if you don't tell it where the part is, or better yet, where the fixture is, right? I don't have that fixture in this file. It'll drive right through.
So that clearance is something that you configured, is what you're saying?
Yep.
Okay.
Yep, that's on the programming side of things. So I'm slowing the speed slider way down again, and I continue. And do you think we want to leave the probe there at the end of a program?
No.
Probably not. One of the problems with me only giving you the inspection file is the inspection file doesn't tell that where to go when it's done. That's a separate file. So whenever we run a part for the first time, we have to do our CNC end part position. Okay, there's our dimension report, by the way. This part wasn't as bad as it looked like before. You remember I ran this before without touching anything, and it told me the part was all bad?
It's a bunch of reds.
That was the old, I ran a different part last time. This is that actual part we're looking at here, right? And even at that, maybe the program was written wrong so that the measured value or the nominal value or the tolerance wasn't configured correctly. So I'm not even panicking about that red yet. I'm gonna go double check all this systematically, make sure it's correct before I freak out. If I confirm that all that stuff is wrong, then I can freak out.
So the Calypso that we installed on our computers, is it referendum to that program, just minus the machine?
Yep,
Okay.
it's exactly the same thing without the machine.
Nice. So we can just toy around with it and try to figure stuff out with like the models and stuff that we have assigned. And, like,
Don't waste your time, just go on CurioZ, it'll tell you everything to do.
okay.
You could do that, and I did do that when I got it, and it's different enough from other softwares.
Yeah.
It's like, could you just start making sounds with your mouth and speak German? Yeah, absolutely. Is it going to be as fast as like reading a German dictionary or something like that that's been translated to English? No, it won't be as fast. And this is a German software, so that's a pretty good analogy, you know. It's like,
Yeah. Yikes.
oh, it's an awesome software. I love it. Anyway, so that's that. Let's just do our CNC end part position. We don't want to leave that there. So we are not clear of the part yet. So I am going to just move this out of the way. Okay, so it was going to clear the part. I slowed it all the way down. That's where it's going to end up at the end of the program, but I don't want people knocking into the probe at the end. So CNC end part position is under the plan pull down, and we'll go to navigation and CNC end part position. This seems intimidating. It's actually extremely simple. We just hit, right now it's off. We hit create new, and notice that it has clearance plane. Well, that's where it's going to end up by default. I'd really like it to be somewhere closer to maybe there, so that way we can move around freely, and then when it approaches, it'll approach in a safe way. So all I hit is position referring to master probe in MC system, which stands for machine coordinate system. So no matter where I put this part, this is the master probe. It's going to look at where the master probe is, and it's going to look at my active probe. And pretending that the master probe is in position, that would bring the active probe to here. It'll just basically save that position with that probe. So I'll click on that. I'll say position referring to master probe and MC system. I'll say OK. Now it has path CNC end part position, which is just its default. And next time I run this, through the magic of this software, it'll end up right there. Now you want to see it end up right there again really quickly? Watch this. No matter what I measure, let's say I only want to measure one feature. Hey, look at that. We have the features menu here. Maybe I just want to measure 2D line number 2. That's this line on this side. I'll hit that, and I'll hit run. And instead of doing a manual alignment, I'm going to do current alignment. I'll spare you the details for now. I will clear the results. I will go in step mode, but this time I'm going to go from feature list, and I'm only going to do the current selection. So I kind of had to toggle a bunch of things over here to do what I wanted to do. But the nice thing is I don't have to rerun the whole program to test the end part position. I can just run this one feature. It's kind of like, why did it move out of the way like that? Anybody know why?
That's clear.
Clearance plane. It's smart enough to look at, it's got your back. It's looking at your clearance plane for you. It's chickadee checking yourself before you wreck yourself. It's doing exactly what you would hope a good friend would do. So Calypso is your friend. So some of that architecture that seems like it's more complicated, oh man, it is not more complicated. It is way simpler than the alternative. You know what our other CMM program would do if you did that? Just smash right into it. It's not smart enough to know that it had to go out before it came around. So if you have it configured correctly, it'll always do that. The problem is when you don't configure it correctly. So that's what we're going to talk about in the programming side of things. So we saw one example of how to set up a part, and I didn't want to show you something this complicated. I mean, that's still very simple by comparison. But I didn't want to show you something this complicated. That's what was on the machine. When we come in next Wednesday or whenever, you're going to be doing simple parts. You see that part right there is fixtured directly to the modular subplate. You're going to be doing that part and other parts that are equally simple. And the whole idea is to get you used to moving these joysticks around, to get you used to how to do a manual alignment, to get you used to that run menu. And the reason that we're doing your ballooning and manual verification stuff for homework is, yeah, you're going to run the CMM, you're going to inspect 10 parts. Then you're also going to manually verify each of those 10 parts, and you're going to submit those to me as part of your lab grade. Now, I would ask you if you have any questions. I have to run off to a meeting, so no questions today. If you have questions, send them to me via email.
Awesome.